G'day everybody and welcome back to my channel. I'm just about to start building the amps, but I'm just in the process of changing these transistors to the ones I just selected in the last video. However, this is proving to be quite annoying because some of the threads are buggered up on this heatsink. I have bolts, nuts, whatever you want to call it, with a screw coming in from the back instead of, you know, how it's traditionally done. And the problem with that is because these diodes are mounted with bolts and nuts too, the two intersect each other. Let me get a light in there. You see the two intersect each other, so in order for me to take out... Actually, let me turn my focus off. Well, put autofocus on. You see what I'm saying? So for me to take one out, I have to take the other out. So now I'm removing diodes because I just changed one transistor on its own, and then I said, okay, I'm just going to take off all the diodes that I need to take off and just get on with it as a batch job, whatever you want to call it. Because doing one at a time is just kind of a bit silly. So, out come the diodes. That's the diodes that I need off. Alright. I'll do this off camera and I'll come back when I'm finished and we'll get started on building these things. Alright, I've made progress. I have the new transistors on the PNP side, and the boards are mounted ready to solder. So there's one thing I'm going to do quickly, and I'll do it off camera so I don't bore you guys, because this video is all about assembly, not cleaning things. But these diode pins, because I've cut them short, there was never any solder up near this end of them. Okay, maybe on a couple, but it's kind of dirty and oxidized and it's not going to take solder too well. So I'm just going to go and clean up all these little legs, stubs, whatever you want to call them, and once that's done I'll come back and we'll start putting everything together. I've got all the boards here ready, got all the components close by ready, so we'll just be building. Alright, I've given them a little bit of a brush up with this brush and some circuit board cleaner, which is a bit stronger than cleaning solvent. I'm not sure it's actually going to be enough of a clean, so I'm just going to see how solder flows on it. The flux in the solder might be enough to do the rest of the job with the heat. Yeah, it takes a little bit longer, but it did flow all the way around the, you know, the sides and the bottom of the pin, so that's okay. It's clean enough, the flux will do the last bit. I just wanted to make sure the solder flows properly. See, the thing is, when pins start oxidizing, sometimes you'll get it where it will just solder on a little bit of the pin and the solder will just wrap around the rest of the pin, but it's not actually flowed onto it. But, you know, so I recommend doing what I just did, doing a little test first. That way you know if you need to clean it more. And you'll see the solder wick around the pin and you'll know if it's flowing. Anyway, assembly time. The first thing I'm going to do is I'm going to get all these transistors soldered to the heatsink. Let me see if I can... Actually, if I turn this around... Yeah, you still don't have much of a view. Okay. I'll pause the video and I'll work something out. Alright, well, we're just going to have to make do how it is. I've propped it up a little bit, but if I prop it up anymore, it's going to be on the wrong angle for me to solder it, and I'm going to get a poor soldering job, so I don't want to do that. We'll get one pin on each end first. I'll just do this other board too, so if I bump it, it's held in place, because I've just got the board sitting straight, like level with the heatsink. So now they're not going to go anywhere. It's, you know, if I bump it, it'll be alright. Now I can just continue soldering. My apologies if you're not going to be able to see much doing it like this, but I don't want to tip it up, like I said, too much and have the solder all try and run downwards, if that makes sense, like in towards the heatsink. Hey, what's going on here? What the hell? What? These are brand new transistors. The freaking pin doesn't take solder. Don't tell me these are fake. Okay, now it's taking it. Like the first pin took it. It was only one pin that did that. So let me keep going. And see. No, they are taking it. That's okay. It does need a bit of solder too, because it's a bigger area that I've got to solder. Yeah, no, it's alright. I didn't have the iron making enough thermal contact with the pin, and I was going a little bit too slow with the solder, how much solder I was feeding in for the size of the pin. It is a little bit hard to get thermal contact with this pin sometimes. The thing is, the iron's really good at making contact with the pad, but not the pin, if that makes sense. This is not because of some coating on the pin. That's not what I'm trying to say. What I'm trying to say is it's just physically awkward to get in here. And I sort of countersunk the holes so that the pins would go in easily, because I'd cut the pins. They don't have nice rounded tips. And where I've countersunk the hole, I'll give you a look in a sec. It effectively means that there's a little, you know, it's only, you know, a fraction of a millimeter, but it's a little ring of area that solder doesn't stick to, because there's just fiberglass there, right? I'll show you what I mean so you're not confused. Oh yeah, doesn't really matter. I'll take the focus lock off. So you see around each hole you can see a little bit of blank fiberglass. I did that to help the pin slide in, but because of that, it's just a little bit hard to get thermal contact between the hole and the pin. And my soldering iron tip wants to touch the board, not the pin so much, if that makes sense. Again, just because of the angle. But I'm glad that it's all good, because that worried me at first. I thought the pin wasn't taking solder. What it is, I can tell, it's the transistor wicking up all the heat into the heatsink, because they mount it to a heatsink. That happens. Oops. I can't see if the solder went behind this pin or if it's just in the front of it. Oh no, it's good. Alright. Anyone ever wonders what's with the strange little torch that I have? Now, I used to have this little J-Car keyring sort of torch thing, and it was basically plastic with like a chrome coating on it, and get this, they used the chrome coating actually as the negative, to get from the negative of the battery all the way back up to the LED, where the sides of this board used to press fit to the case. Anyway, the chrome was flaking off, and the button wasn't working properly, so I just took the LED out and soldered a couple of wires and a switch on it, you know. Does the job. Sorry, I should not have aimed that at the camera. I don't think sometimes. I really didn't mean to shine a light in your eyes. I hope I didn't. My apologies if my head's gone under the camera a couple of times. I'm trying to keep it out. I'm about to make a new camera setup that's even better than this. Although I haven't said nothing for a few weeks about it, I am still conscious of the fact that my head gets under the camera, and I have been thinking about what I can do, and I finally come up with a better plan. I'm basically going to get the camera just a little bit further down to the mat, but what I want to do is I want to make sort of a little platform I can sit it on that I can angle it forwards or back. So a good example is this board that I'm doing right now. So I could have the phone sort of out here and then angle it in, and vice versa like that. So, and the phone's going to be just a little bit lower so that I can do this. You see how much better that looks? Yeah. So that's what I've been thinking about doing, and that's what I'm going to do soon. I've just got to cobble something together to prop it up, hold it, whatever you want to call it. Anyway, I'll get there. I've got to remember to keep my soldering iron tip clean, because it's not that it's really dirty, but because it's so hard to get enough heat into these transistors with them on the heatsink, just that little bit of dirt makes the difference between getting it and not getting it, if that makes sense. I could turn my heat up a little bit more, but it's already at 370. I know some people solder at crazy temperatures, but I don't like to, unless it's going to take too long. Like this is actually starting to make me a bit uncomfortable. I don't know why. A couple of these pins have just taken too long. Like that pin and that pin took a long time and the rest didn't. I don't know. I might turn it up a little bit. We'll see how we go. The transistors can get rid of the heat basically straight away, but it's still not good. Wonder if my heatsink's warm yet. No. If it was a smaller heatsink, it would be. I can tell you that, because I've soldered transistors on smaller heatsinks. I'll give you an example, like a BLDC controller, motor controller. Yeah, the collector pins are impossible to solder to, and I know exactly why. It's because the collector goes straight to the center of the die, and the heat spreader, it's all one piece. If you smash a transistor open, you'll see that the collector pin and the heat spreader is one piece, and the die's on top of that. So you're going to get the heat straight out the back of it, and it's going to be the most thermally conductive leg, the collector. The other two just go to little bond wires, you see. I might have actually screwed something else up here. It's not terrible. I'll be able to make it fit, but I'm not happy about it. Where the emitter resistors go, yeah, they'll just fit. I should have brought these tracks all out a little bit further. It'll be alright though. Well, that's the transistors all soldered down. Shit, I forgot to lock my focus. I'll do that in a sec. Cool. Alright. Heatsink number 1 is complete. On to number 2. Turn it up another 10 degrees. Oops. This is exactly why I wanted to do this. So if I bump it like that, I don't have to keep straightening it. Alright, back to this. I am so keen to get these amps built. I have not had a decent setup in my living room for some time. My last system was decent, but I had a couple of rabbits here, and you wouldn't believe what they did. They managed to get to my bottom. So I had these. Well, I still got the boxes and the subs, but the subs need new surrounds. Incidentally, I'm going with different subs I have. I've got heaps of different subs. I've got 12-inch subs, 10-inch subs, a couple of 15s. I've got 8-inch kickers. I've got so many different subs. Anyway, I had 8-inch kickers in these tower boxes that I built, ported at the back, down the bottom, and the bloody rabbits climbed up the front with, like, just stood on their back paws sort of thing, and they ate all the rubber foam, whatever you want to call it, surrounds out of the bottom two kickers. Now, kickers are shit speakers. Incidentally, the rest of the foam ended up rotting out not long after that, and I bought them brand new from Strathfield Car Radios. They were only maybe 2 years old, and the foam rotted out. Now, I was powering them at the maximum power that you could give them, and they were moving, playing crazy frequencies too. By crazy, I mean, you know, 15 hertz, 20 hertz, 25 hertz, and yeah, but it wasn't from them going in and out. It wasn't the X-Max that made them tear their surrounds. It actually started to rot. Anyway, I still got them because the voice coils are great, the cones are great, the whole motor assembly is great, you know, and the cone's fine. So I just need to get new surrounds for them, but I want to get a different type of surround. But obviously I need to match the parameters. Can't just go put any surround in there. I've got a couple of old JL 12W3s, or 12V3, I can't remember, famous subs. Nice old school ones. I've got to rebuild them. I'm going to put them in a couple of ported boxes and see how efficient they are, because they're only like 300 or 500 watts each. They're not too powerful for a 12-inch sub. They are dual voice coil, but still, but because they're from like the 90s or whatever, they're probably a lot more efficient in dB per meter than today's speakers. So I wouldn't be surprised if they're actually more than loud enough for my purpose. So the only way I'm going to find that out is by sticking them in boxes and having a listen. I mean, I could have a look at the data sheet for them, but I want to put them in boxes anyway. I got them to restore them. I got them from a friend who used to have them in his car boot when he was younger. He's a bit older than me, so like they're old speakers, you know. What on earth? Every so often one pin just will not, like, this is ridiculous. Just will not take solder. Luckily they're on a heatsink. There is no way I would give it that much heat if it wasn't on a heatsink. There's something in there and I'm not sure what it was. It might have just been flux, but I wasn't going to take my risk in case it was a bit of fiberglass filing with copper still attached to it. That would not be good getting between the pins. Not at all. These collectors are bloody hard to solder. If the heatsink wasn't all jacked up, I would just, you know, solder the transistors to the board and then mount the board to the heatsink. But because I have to do half the screws one way and half the other way, it's a lot easier to do each transistor on its own, if that makes sense. So this is just one of those builds where, you know, I'm trying to reuse something that's been literally reused 100 times already. It's, you know, it's effed. I really need a new heatsink, well, new heat sinks, but I figured that's still fine, you know, I can just make the holes bigger and use bolts, it's all good. They're beautiful heat sinks apart from the fact that the holes are stripped out, you know. Okay, one's got a few extra holes on the top of it too, but like I said, I've used them for things, you know. I've had these for years. They were in a huge PA amplifier that I used and pumped the crap out of for years. And then I've used them for different things, and now they're getting another life again. So, I mean, it's good in my books. Alright, we have devices mounted to the heatsink. Now, I'm pretty sure one or two of the holes where the emitter resistors go in I filled by accident. Yes, one there. Let's see. I'll just look at the other heatsink. No. So just one hole. See if I can get that quickly now. Where is it? There it is. Oh, that's the collector. What am I doing? God. The pin that was so hard to solder, I've just taken all the solder off. Oh, man. Alright, let's go for the emitter now. Okay, I got it. I'm just going to carefully put some solder back around the pin without flooding the hole. Okay, beautiful. I'll lock the focus now that this is done. I do still forget that sometimes, I'm not going to lie, I'm sorry. I don't know what happened with the last video that I uploaded. Maybe not the last one, the one before that, but obviously I forgot to lock the focus, and the focus was just going in and out, but normally it seems to just go a little bit dimmer and then a little bit brighter. This time when I watched the video, it was really going all the way dim and then really bright and then really dim. My apologies, I have no idea what happened there, other than that I forgot to lock the focus, which I just did again. There we go. The other thing I want to say is sorry about the 4 minutes of sideways segment. I realised that, and I thought, well, here's the screwed up thing is, actually, you know what, I probably can turn that around in editing at the sacrifice of a little bit of quality, maybe. I'll have to look into that. Damn, these emitter resistors are not fitting how I wanted them to. Okay. I do have an option to put them in from the bottom. Could do that. I don't like it, but I've got the holes so close to the transistor, you know. Also, heat risers, having them underneath, the transistor's not going to heat the resistor's only going to have its own heat, which is going to rise up the legs. Actually, that's an effective heatsink. You know what? I like that. Let's do that. Like I said, I don't mind so much if something works electrically. And this works electrically, so let's do it. I want to get decent quality out of these amps too. I'll just do 4 at a time. No, I don't work in a sweatshop. I'm just really fast at soldering. It's just one of those things you get used to, you know. I'm sure a lot of people watching this channel already solder, so you know exactly what I'm talking about. Yeah, I'm happy with that. That's fine. Doesn't have to look perfect. It just has to run perfect. I'm really happy at the outcome I've got with the transistors. I mean, those extra tip 41s and tip 42s that I just bought off AliExpress, getting a different brand, a different batch, that was just luck, and it was very good luck, and I'm really happy I did that because now my drivers are matched. The VB is literally perfectly matched, and the HFE is off by about 20, which is all right. You usually aim to get HFE within 10, but that's if you're going with a design where everything has to be matched. Now, this design, everything doesn't have to be matched. It would just be a lot better if it is. So 20 is all right for this, you know. And the fact that the VBE is perfectly matched, you know, that's the real winner part, you know, winning. It's, what do you call it? You know what I'm trying to say. Rise to fame. All right. Layers are in there. This mat's annoying. Handy but annoying. Cool. Snip, snip again. What was that? Oh, there's already a leg in here. Yeah, something felt funny when I was cutting the other side. I'm just going to have a quick look and make sure I didn't grab a transistor leg at the same time. No, it must have been the same thing that happened to me. I got good eyesight and I can tell there's not even a scratch on one of those pins, so it wasn't that. All right, well, that's a little bit lower. Oh well. That's the emitter resistors on one board. Let's get the other board done. Alright, I'm happy with that. I'll give you guys a good look inside when I finish this one. I didn't turn it up last time with the other heatsink. At least now as we get to the front of the board, you guys can see what's going on too, not just me. That's a lot better. All right, last 4. The reason I'm pushing them in is to make the lead length as short as possible. You know, anything that's small and thin is going to be more inductive, so you want to keep it short. This is also the same reason why when I make up my own PCBs, I make really thick traces where a lot of people would not. The way I see it is, I mean, it benefits me in 2 ways. I have less inductance and I use less etching solution. The only time I will make my traces smaller is if it's going to be an area problem, as in because the trace is too wide or too long, it has too much area. Say it's a high impedance node and it's susceptible to noise or something like that, you know, then I might do it a bit different, like a small trace with a ground plane around it or a guard trace or whatever it is. But usually, you know, I'll go for the bigger trace. All right. Don't worry, I didn't cut the transistor leg, it's just these pins getting stuck back in the cutters. Alright, so that's 2 heat sinks with transistors down and resistors down. We're getting there. Alright, that's good enough. Try and make it look neat. Okay, I think the next thing I'm going to do, I want to get the base resistors in. We'll do the base resistors and then we'll do the cross distortion resistors that go, that's what I call them because they turn the transistors off quicker. I'm not sure if that's the actual name. I coin a lot of my own terms in electronics, you know. And the funny thing is, sometimes when I do a little bit of research, it ends up being the correct term. That's when it's really funny. Anyway, I need to go have a toilet break, so I'll be back momentarily. Alright, I'm going to get started on the base resistors now. I've actually been contemplating using SMD resistors. I might get some and measure the inductance on them. The reason being is because, I'll just show you. It's such a small distance to cover. Although they might be metal film, not carbon film, because they're 1%. I don't know. Let me have a quick look. Oh, I grabbed the wrong size, my apologies. Alright. Got the larger 0805 book. 2.2. Here we are. Let's just get one out. Actually, you know what? Even that's a bit smaller than what I thought it was. Yeah, that's actually too small for some of them. We'll just go with what we've got. That's alright. I'll pause the video whilst I put these back. Sorry about that. Alright, so in this case, what I'm going to do is what I was just about to do. I don't need much length on them at all. I'm just trying to work out how I'm going to orient them. I think what I'll do is I'll preform them all. Yeah, I only need the smallest little bit. I wish I had have inverted the layout of these output boards. I'm actually meant to invert it so everything went into holes and the traces were on the bottom, not the top. Luckily, it doesn't matter. Let me just think about this. Luckily, it doesn't really matter because this is going to be inside a case with just a bit of the heat sink and some fans sticking out the sides or the back. So it's not like it's going to, you know, have the risk of stuff landing on top of the board. Yeah. This is what I'm going to do. I'll just form up one of these on camera and then I'll do the rest off camera. I'm basically making them into miniature, kind of like surface mount parts. You know what, I'm going to have to pre-tin these as well. This is annoying. Man, I really wish I flipped these boards. I mean, inverted the layout so that when I went to assemble it, I could, you know, just put everything in holes. These are going to be fiddly and slow to do, so I'll just do this one, and then I'll pause the camera and do the rest so you guys don't have to feel the pain with me. That works. And it is where I want it, so that's good. Oh yeah, that's great. You know, it doesn't come out too bad. I mean, sorry, let me just unlock the auto, so the focus. That doesn't come out bad at all. I mean, I do this a lot. This is, sorry, This is my technique for laying through-hole components on PCBs without drilling holes, so I'm quite used to doing this. But yeah, I mean, that doesn't look bad at all, if you ask me. Leave it in the comments down below what you think. Like I said in the other video, I think as long as the parts, you know, are small like this and they don't weigh a lot, it's fine. It's, you know, it's basically SMD. SMD stuff's all laid on the top of the board. Alright, I'll get the rest of these mounted on both the heat sinks and then I'll come back. Alright, this is the last one going in now. Last base resistor. I'll give you guys a look at them. Yeah, great. I just spooled my solder around the axle that the spool goes on. Spindle. Couldn't think of the word. I'll just take the auto lock off. So that's that. Alright, next thing I'm going to do, now the base resistors are on, is the two 100 ohm resistors that go across each side. Just grabbing them. Got all my components right here. So what I need to do with these is I need to put two together quite close in the middle. That should be fine. And then those two need to go between these holes. Well, it would help if I soldered the two together first and cut the leg off. So I'll just do that quickly. Like so. That's my 200 ohm resistor with a center point. Is that going to be too close to that? Let's see. You know what, let's go from the bottom. Might go in the back first because it's going to be trickier to get to it once I've put the front one in. Trying to make it all nice and neat in the middle, but it's not going to plan. That'll do. Doesn't have to be perfect. That basically is perfect. Alright, I'll cut the rest of that off afterwards. I'll make the rest of these up. I'll twist these all together and solder them in a batch. Oops. I'm actually not complaining that these resistors are going across the board. Oh no, these aren't what I thought they are. These are the cross distortion resistors. I was thinking of the 220 ohm resistors that go in series on the BIOS network, because the single transistor preamp design, even if I give it, a current source and stuff like that, it gets capacitively coupled, so it goes to the center point of those 220 ohm resistors. Nothing to do with this. It's just getting late and I'm getting tired and my brain's not working properly. Should have paused the video to do this. Although I don't really know what people like watching. Leave it in the comments. But there again, I sort of try to title my videos so that you know what's happening in the video. So, I mean, I guess people shouldn't really be watching videos unless they want to watch them. So, I hope I'm doing the right thing. Anyway, a lot of people don't actually build stuff on camera. They just show their work or do what I do going in between scenes. But I try and show you a bit of the work getting done too. Like you notice, like I'll do a couple of resistors. I'll go do the rest off camera. But I'll show you a bit of the work too. I don't just do it all off camera and come back in segments. I don't know. Leave in the comment section what you think is a good method, if I'm doing a good job or not, because I don't want to bore people, and I constantly want to improve my video skills, like what I should be showing that is entertaining to people. I want to get good at that. Oops, almost went for the wrong hole, man. That'll do. All right. I think I'll just hold it down like that and then cut it. I don't want to go around and around and around and around, because if this gets smoked and I have to do a rebuild, usually the components that will get smoked in a triple Darlington when it turns to crap is the cross distortion resistors, the output resistors, base resistors sometimes, and the output devices and drivers. Sometimes even the buffers. Usually not, in my experience, surprisingly, but it can happen. So I want to leave that stuff sort of accessible, Obviously I'm going to be careful and try not to blow it up, but just in case something goes wrong in building it, and I power it up and the smoke comes out. I mean, like I say, I'm going to go over everything with a fine-tooth comb. I'm going to, you know, be careful. I'm going to power it up slowly. I'm going to do everything I can to not let that happen. But, you know, sometimes you think everything's all right and you turn something on and it seems all good for a second, and then as soon as the transistors reach their bias point and turn on, boom, the thing goes bang, you know. It's just, sometimes you don't know until it's too late. Especially when you've got a capacitor bank and silicon that turns on randomly, you know, it can be quite hard to make that call sometimes. I think the next thing I'll do, they need to be wired in between the emitters of that transistor and that transistor and that transistor and that transistor respectively. And I need to hook up all these base points over to the emitters too. So we've got multiple things that need to get joined to the emitters. What I'm thinking is with the bases on these, I'm quite tempted to just get some tinned copper wire and go from here to here to here in one piece. Because I've got the 2.2 ohm resistors, I don't think the daisy chaining it's going to have an effect on dissipating more power in one than the other. The 2.2 ohm resistor should, you know, take up the slack. Yeah, I think I'm just going to do that. That's fine. 2.2 ohms is, it's, you know, it's so many orders of magnitude more than the resistance in that length. It's not going to make a difference. And, you know, I'm quite fussy on stuff like that. So if I'm not worried about it, it's really not going to make a difference. Sure, someone out there will disagree. I'm just working this out as I go, so let's see. Thinking if I just directly solder it. You know what? No, I'm going to run wire from each base pad directly to the emitter of the driver. Yeah, that's what I'm going to do. I'll go get some wire and cut it up. I don't know. Excuse me. I can't decide, eh? I really can't decide. I'm trying to think of what's going to look better too, because like I said, the 2.2 ohm resistors are going to take up the slack, so I don't really need to worry about them. I mean, about the daisy chaining effect. I'll pause the video, go get myself another drink, because I don't have a drink in here at the moment, and I want one. And anyway, I'll be back in a minute, and I'll make my mind up. Alright, so I've decided upon going without the wire, just using the link. Because of the resistors, it's not going to matter, and because I've already got to add an extra wire from these resistors, I don't need 3 wires to try and solder down to one pad, you know. So I've decided to do this. That's happening. And I can literally just fold it around, bring it to the pad, solder it down to the pad. I'm going to have to tin the wire first, but I don't have to cut it and do it in 2 pieces, you know. See? And then I'll just give this a little end. And I'll turn this around so it faces in where it's got to go, and then solder it down. Guess this one's going to get tinned in situ. Yeah, that works. Now I'm just going to add a little bit more solder to the other two joints. Made a mess of that. Oh, stop it! Get out! These bloody cats. They do my head in sometimes. I had it so perfect and I screwed it up. I should have just left it. Alright, now that's perfect, so just give that a bend so that it's not going to lift up when it gets heated. Oh, that's not solder. Alright. I'll do one more of these and then I'll go do the rest off camera again. This one's a little bit more tricky to loop around. I'm gonna have to have a little bit of a think about this. Let's try this. Oh, you know what? It looks tricky, but once you've bent the wire and brought it in, it's actually alright. I'll bring this up to the camera so you can have a look after I solder this one in. You'll see what I mean. It's actually quite doable. Now that it's down to a little spot where I've creased the wire, it's a lot easier to fit it into this tight spot. I know it doesn't really make sense. I'll just show you in a minute. All right, I'm happy with that. If I was really worried about it, I could put insulation over it, but I'll be honest, I'm actually not. I'll give you a look at it. Gotta take my focus lock off. That does the trick. There's more space than what it looks like. Alright, well, I'll go do that for the rest of the other 3 banks, and then I'll come back and we'll get the wires attached to the end of these resistors going over to these emitters, and then I think we'll put the base resistors in for the drivers, and then we'll start with the Zable network. And that's it for the output stage. Alright, I'll be back shortly. Something I just want to point out, the reason why I was really or am really concerned with, making sure the drivers were as matched as they could be, low inductance, keeping everything symmetrical in terms of like the length of traces and the resistance of traces and starring stuff. The thing is, your input section and your output stage, especially the output stage, is the part of your amplifier that's going to create the most distortion. So you want to pay attention to these areas. And that's why. Incidentally, I've moved this bit out a little bit more just to give it some more clearance. Anyway, I shall continue wiring up these base resistors. Alright, I'm just getting the last link for the base resistors installed now. So, about to do the next part, which is going to be installing, well, they're installed, connecting up the cross distortion resistors, as I call them. Not happy with that. That's better. I'll have to give that a bit of a bend to make sure it's in the right spot and stays there. Alright, and then I'll reflow it again afterwards. Just get this other end down to the emitter, and then I'll come back and reflow it. I'm trying to keep everything looking as neat as possible. You'll be amazed what I can pull off for something that's just put together like this. I mean, without the use of traditional through-hole assembly. Now I'm happy with that. All right. I'm very happy with that. Oh no, I didn't lock the camera. Sorry. Anyway, I'll go get a couple of bits of wire now. Oops. And we'll start with these resistors. Alright, I'm choosing black for this. I just think that it looks the part, you know, it blends in, it's a good contrast with the silver, it doesn't stand out on the board, it matches the devices. I just think it's the best colour to choose here. Just thinking. Yeah, I'll do this to here. Just trying to work out if I want to use the front or the back bank of resistors for the first bank or second bank of transistors. I know that's a little bit confusing. Just do one piece at a time. I think what I'll do is I'll put these 2 bits of wire down on camera, and again I'll go and do the rest off camera, and then I'll come back. That way, again, everyone gets to have a little look at what I'm doing, but at the same time, you just don't get bored watching me solder the same thing 8 times or 16 times, whatever it is. Just pause the video before I even soldered it. Alright, you know what I probably should have done? Probably should have soldered the wire, the wire around the resistors first. Yeah, I'll just put that in the scrap box and I'll cut another piece of wire. Although, you know what? No, because if I have to pull this apart, that's going to be absolutely terrible. I'll just make a little hole with the resistor leg so I can slide this in here. And then I'll solder it to the resistor leg. That way it's nice and secure in there, but I also can take it out easy. Yeah, I'm much happier with that. I think I'll solder this at that node there. Yeah. And I'll go straight down with it. Just add some more solder. Yeah, cool. That works out nicely. I'm happy about where the wire is. Yeah, cool. Alright, I'll pause the video. I'll do this other little wire first, just so you'll get an idea of how this is going. And then I'll just go and do the rest off camera so I don't bore everybody. Leave in the comment section if that's a good way of building stuff on camera when I'm doing building videos, you know, because like most electronics channels, I have different videos with different types of content, you know, but when I'm doing my building videos, I want to find the right ratio, if that makes sense, between building, talking, showing, you know what I mean? Actually, that could be a bit tighter. Cool. Yeah, that's good. I like that because I can just heat it up and pull the wire out, you know. And then the resistor's only got one hook. obviously if I had drilled holes, it'd be much simpler to just put stuff in through holes. But I'm saying I'm trying to make it as easy as I can given what I've created. So that if something does turn sour, either in the building process or in the future of using this thing, it's not a nightmare to get everything out of it. Just a little trick I have to, you just keep blowing on the bit you're soldering at as you applying the solder, and it stops the smoke from coming up in your face. It goes out over there, you know. That's what I do anyway. Alright, I'll go do the rest on camera. So now I've got to do the same with this. So it's, you know, one side's got to go there, the other side's got to go there. This side, actually, I think it might just go onto this wire. Oh no, I'll do it at the base terminals, emitter terminals, yeah. I'll do this one on camera too because it's going to be a little bit different to the other one. What am I doing trying to cut the wire? I never do good working and talking at the same time. It doesn't work. All right. I want to put a little bit more solder on that, but oh shit, that's the wrong wire, wrong side. Good. That's not good. No. No. No way. You know what? Yeah. I'm just going to cut this wire back a little bit where the insulation's not melted. This is just going to get soldered directly to this piece of metal that goes to the two bases from the emitter of the driver. Bit ugly, I know. Didn't go to plan. Alright. At least the wires are going crossways, so they're not going to couple into each other, because the fields aren't aligned. They're only aligned when the wires are next to each other. So that's good. That stops coupling, because you don't want coupling between channels. It's tricky trying to build an output stage up in a NPN and a PNP half like this. Yeah, I'm going to cut this shorter and solder it to the wire too. I want everything to be symmetrical. If it's soldered to the wire on one side, we'll do it the same on the other side too. I mean, that's probably the best place for it to go anyway. I know a lot of people are probably going to look at this and go, oh, what happens when the solder cracks and it comes off the wire? I globbed that on quite well, and I'll tell you now, I've been doing electronics since I was a little kid, and I'm 33 soon, and I've not yet had a wire or anything that I've soldered just pop off. So I'm not saying that you don't get dry joints on circuit boards and stuff like that, but you know, half of that's because it's soldered quick. The other half of it's because of heat cycling and stuff like that, you know. I guess this is an output stage. It will be heat cycling, so maybe one day in the future this will pop off and it'll be a first for me, but oh well. If it happens, I'll be sure to let you know. And you can laugh at me. All right. I'll go do that to the other amp and then come back. Every time I look at the board, because the emitter resistors are under here, I keep thinking that I haven't done the emitter resistors yet, and I'm like, what? Ah, goodness. Actually, just swap them, eh? Alright, I'll be back soon. Alright, so I've done both these. I did go back and just change the positioning of a couple of these wires because they're really close to these pads. Hold on, I'll have to stand up to get this on camera. Oh, I need to unlock my... There we go. So now there's spaces. Anyway, that's that. Time to put driver resistors, and then we can build our Zobel network, and then we have an output stage. Most likely a video too, it's probably getting quite long by now. Alright, I'm going to do the same thing to these resistors. I'll do this off camera because this is going to be boring. And I'll come back when I've got all these formed up. You know, before when I was saying leave it down in the comments what you think about mounting surface mount components to the top of the board like this. That is excluding the fact that you have to form all the leads first, because that does take more time. It might be quicker to take the components off, but it does take longer to put them on than just sticking it through a through hole, you know. But when I was saying what do you think about it, I mainly meant from a electrical, mechanical stress, all that sort of standpoint of view, not so much God, I've had a brain blank. I'm really bad at working and talking, aren't I? You know what I'm trying to say anyway. Yeah, leave it down there. Made a mess of this one. It'll do. Lucky last. Alright, I'll get them tinned up and I'll come back. I'll do that off camera so I don't bore you guys. Alright, those resistors are all tinned, so let's start getting them into place. I think I'll put the heatsink like this. Yeah, that's good. Actually, we need blobs of solder on these pads. Just on one pad so that I can place the resistor leg down flat with the other pad before putting solder on it. I'll show you what I mean. So I can flow it into the one I've just put solder on, and you see the resistor's flat on this pad. Well, it is now. So now when I come to solder it, it's not, you know, some distance away from the pad, it's actually on the pad. Oops. Last resistor for this board. Well, not the last resistor, but the last one of these particular style and ohmage of resistor for this board. Alright, I'll get the other board done. I'll do that off camera. I'll give you guys a quick look at how it's coming along too. Alright. Be back soon. Alright, that's the rest of the base resistors installed. Something just occurred to me. I'm going to want to drill another 4 holes near those base resistors so I can bring a wire up from the bottom of the board as well. Pretty easy. I'll go do that now. I'll be back in a sec. Alright, we now have holes for the base wires. Cool. Alright. I think we'll do the Zobel networks. So I'll get my 250 volt 100 nanofarad capacitors, my 47 ohm resistors, and the other values gone blank. My inductors and my 4.7 ohm resistor. Oh, my apologies, I meant to pause that. Well, I did, but I must have double tapped it because it's still recording. Also, I left one inductor. That's better. Alright, two of these inductors I need to drill bigger holes for. I drilled the holes the right size for these ones. Actually, I don't even think that fits. No, it does. It does. Okay, cool. Alright. I need to prepare the inductors. That's alright. We'll solder them and the resistors last anyway because these are the smaller components. We'll put these in and then we will put our inductors and resistors on. And after that's done, then we can put the bias board on. I'm saving the bias boards to last because I don't want, little man, I don't want it to be a difficult thing. That's the wrong one. That's perfect. Cool. I don't want it to be difficult soldering in there, so we've done that first. Little man, can you be quiet? Stop it. Little man's a strange cat. What's wrong? Little man. He just wants attention. He just does this sometimes at the most random times, like for no reason. You see what I mean? Little man. Hello. You love complaining, don't you? Hey! Alright, you can go now. Sorry, that was bad. Where were we? Capacitors. Little man. I might have to take the cats out the room in a sec. Seems that they're going to start being a bit troublesome in here. This is probably the largest component that I would solder on top of a board without putting through holes. I mean, I have done larger components like the capacitors on these little switching power supplies I showed you guys, but I don't really like it. I even used that as an example in the last video of what not to do, so, you know. Alright. So how have I done this? I've got resistor, capacitor. Alright. let's tin these. And we'll tin the pads, or leave a little blob on the pads. Dude. Right, that's set. All right, that's one. Put these ones on. I really need to clean my soldering sponge. It was clean, but when you're doing like production style soldering like this, you'll be surprised how dirty it gets quick. All right, that's them. Gotta remember to turn that focus on. It's hard when I'm doing something like this, going back between it on and off and on and off. It's hard to remember. All right, 47 ohm resistors. Let's see what we can do with these. Oh yeah, perfect. Anything that's a power device that could get hot, it's a good idea to stand a bit up off the board. Still, I'm not making it too high because I don't want inductance getting added to everything, but it is stood up off the board a little bit. The other thing that you've got to judge when deciding how high to stand something up is how hot it gets too. If something gets really hot, you've got to stand it up a bit more than if it only gets warm, for example, you know? Stand it up higher. Okay, I'll tin these. I'll pause the video whilst I tin them. Oh, it'll only take a sec, eh? No, I'll pause it. It's getting long, isn't it? Alright, I've tinned the resistors, so now I'm just going to add some solder to these pads. Now that bothers me that the resistor's got the wire resting on it. I don't like that. Yeah, I think I'll just do that. Just tuck it in a little bit. Just slightly. I don't like the look of it, but again, I'd rather everything be electrically sound than look pretty, you know? Yeah, I'll just put them all in on an angle, just a little bit like that, so it looks even for everything. All right. Our lucky last resistor. Well, for these boards that is. There's still plenty more resistors to be soldered down. Plenty more. That one had shorter pads than what it should have. Oh well. Good enough. Everything looks fairly decent. It's not too odd. I know these resistors are around the opposite way to each other, but it is what it is. I drilled the holes where I had space, and you know, none of the boards were exactly identical. Alright, I'll go drill a couple of bigger holes because I haven't glued these coils. What I decided to do is when they're soldered, because these pins will be stable, I can just put a cable tie through them and then put some glue on it and then cut the cable tie out in the morning and they'll just be stuck in place. I'm not so much worried about the actual value of them. I don't really care if it's 1.5 microhenries, 2 microhenries, 1 microhenry, you know, as long as it's in that ballpark. So the thing I'm more worried about is them being able to vibrate with music playing through them because they're, you know, inductors, and the inductance value changing with movement. So, you know, that's what I'm going to do. So I'll go make 2 of these holes bigger for the bigger 2 coils. That's also why I've just wound this the same amount of turns as that, even though this is 1.5, I think, and that's 1.75, or that's 2 and that's 1.75, the diameter. You know, these coils I wound myself will have a little bit more inductance than that, but it doesn't bother me, like I said. And all the resistors for them are 4.7 ohm resistors. Alright, so I've drilled the holes out and I've also stuck the resistors in the board. I've got to still solder them, so I'm going to do that now. Okay, this is really odd. What the hell? What? You know what? This is a weird phenomena, but where I've countersunk some of the holes, the solder doesn't, it's very tricky to get it to actually get on the component leg. That took an effort to get that in. At least it's a resistor, I can get it hot without worrying. I mean, to a degree. If you did keep getting any component really, really hot, even if it could take it, eventually you would carbonize the legs where they go in and connects to the component inside and end up with a high resistance connection. So I guess even a resistor, you can't just get unlimitedly hot, you know, but they can take a lot. This one's going to be the same deal. Yeah. Got it. Let's see what the problem is. I can explain why this is happening now. So what's happening is where I've countersunk the hole a little bit, it's actually pulling the dirt in. So instead of the dirt trying to float on top as the flux brings it out, it's sort of bringing the dirt in to the center where the pin is. And that's obviously really screwing it up. All right, lesson learnt, don't countersink holes that you're going to solder. That's all good. Great. Did that solder dry? Yeah, okay, that solder dried first. All right. I was worried that that just went everywhere. That fucking magnet is pissing me off. We'll do it like that. All right. I'll just clean that up because that looks terrible. Yeah. I don't know what that is. Ah, that's glue. Okay. All good. I've come across this before. It's either glue or old flux, but it doesn't harm the soldering process. Alright, these should fit in these holes now. Oh, I've got the wrong heatsink here. Yeah, I've got the wrong heatsink here. Oh, that's a bit of a squeeze with the resistor there. A bit of a squeeze. Actually, that works. Not straight. All right. Yeah, I never measured these big coils. I think I just eyed it up to the ones that I wound. I never measured anything, I only did it all by eye, but I didn't take into consideration that these two coils were bigger. Boy, the solder really does not want to flow. Actually, it might just be dirt that's floating to the surface on this one that's tricking my eye, but yeah, I didn't like the look of that. I think it's just burnt glue. Alright, well that's those two inductors in. Alright. These ones I've got to scrape the enamel off, so I'll go do that now. And I'll be back momentarily. I'm so sorry. I just looked at my phone and it wasn't recording. I've been sitting here, I've installed all the inductors and resistors and trimmed off the excess on the bottom. I started doing the bias strip. I went to look up at my phone. It wasn't recording. I have no clue why. Because when I came back, I hit record, but it just didn't record. So the screen mustn't have registered. That's all I can make of it. Anyway, we are doing the bias strip now, so yeah. Alright. I'll just make sure these other pins are flush with the board. Alright, I'm happy with that. Because we certainly don't need this to come disconnected in operation. Our bias voltage would shoot through the roof, literally. And the current, the entire bias would just go, see you later. I'm taking your transistors. God, that lump is so annoying. Alright, that's the bias strip. Obviously we still have to fit components on the bias strip, but that is the bias strip. Starting to come together as a little module. You know, that's pretty compact for a 500 watt amp. It's not bad when you think about it. The driver board, you know, that's not bad. Not bad at all. I like it. There again, I built it. Of course I like it. I am aware of this scratch here that looks like it goes all the way through the copper. In fact, I'm going to address that now rather than later in case I forget about it, because that would be bad. I don't know if that even showed on camera, but there is a little split there. I'm just not sure if it goes all the way through. Even if it doesn't, I'd rather do that anyway, because there's a little crack there. You know, who knows how thin the copper is underneath it, and you know, if that corrodes over time, that could end up all the way through. There's a couple more little nicks there that I'm just going to patch. I know it doesn't make it look nice, but you know, I'm more worried in the bias string going open circuit than it looking pretty. I'm happy with that. All right, let's get the second bias string on the second amp. Wonder if I'm going to be as lucky. Let's see if I can get this to hold it by itself. Damn it, this board's a little bit lopsided. I might get away with this. This is how I got the other one done when I thought my camera was recording and it wasn't. Let's just see if we can get this. Looks like it. Yep. Beautiful. couldn't ask for more. Alright, get these all flush and we'll start soldering. At least you get to see one of these getting made up, because certainly didn't record the other one. I'm going to have to get up and fix that sponge because I'm just dragging carbon all over it because it's going dry, which will ruin it. Now that sponge is already old and needs to be changed anyway, so I'm not too concerned about it. Still, I am using it. The reason I move the iron around and play with the solder is to pull the dirt out as it comes to the surface underneath the leg. So the solder's definitely flowed all the way around the leg. And don't worry, diodes take heat better than any other silicon that exists. Plus, these are big chunky diodes, plus they're mounted to a heatsink. So it's, I'm not going to damage them just doing this. And something just occurred to me. I haven't tested these diodes. I didn't like having to do that, but those legs were really oxidized. Diode's still cold. The heatsink's so good at pulling the heat out of everything. But you still do get the heat going up the leg and through the silicon in order to get to the heatsink. So just because it's cold doesn't mean that 370 degrees wasn't going through it. It was. Yeah, some of these are really oxidized. Not as bad as it looks, but we will be cleaning up all flux residue and stuff afterwards, so don't worry about mess. Oh no. Oh no. I don't remember that happening. Apparently I soldered something live. I've got a little blowhole in the end of this tip. Because I changed this tip recently. I must have done it a really long time ago and I don't remember, but because I've put an older tip back in, it's got an old blowhole on it. No, that wouldn't be from soldering something live because I didn't think it was plugged in. I would have been working on something live and thought that I was on a floating area and been lazy and not disconnected the grounds to the soldering iron, and it would have gone bang. I could see a younger version of me doing that. Again, These days I wouldn't do something like that, but yeah, a few years ago I would. In fact, when I started getting back into electronics, I was very lazy. But then I started creating more work for myself by being lazy. So I got out of that habit pretty quick smart, you know. The way these amps were built with all that point-to-point wiring is a classic example of that. Now I have the patience to make up boards and do all this, you know. Anyway, now we need to start deciding on how to lay this out. So we need 4 500 ohm single turn pots. We need 8 120 ohm resistors, 4 560 ohm resistors. This should be it. Everything else goes on the circuit board. Yes. I've got all my components just on a sheet. A plastic bag, incidentally, just to the left. The bigger components are still just over there. But everything is close by. So I need to really pay attention here. I need to go to the toilet, so I'll do that, and whilst I got the video paused, I'll stare at this and work out exactly where everything goes, so I'm not sitting here on camera going, you know, they're coming along. If anyone spotted that bit of wire that was close to that, I just trimmed it off, and I'm going to have a quick look under here too. Alright, always check your work as you go. Something else I didn't used to do, which used to come and bite me in the arse. Alright. You know, I just thought of something. Having diodes this big probably has an advantage, because these are in between the bases on the first drivers or buffers, whatever you want to call them. Now, I don't know how many people are familiar with diode clipping circuits and what happens when you have a diode in a signal path, but basically they cause distortion. Now, the harder the knee of the diode, the more distortion it will cause. Higher current diodes are going to have what looks like a softer knee when you feed them a small current. I don't know if that makes sense or not, but oh hey, I missed a leg. At a small current, the knee or the turning on point, it's going to be very gradual. You know, if you've got a big diode and you give it a big current, yeah, it'll be fast. But if it's limited, which this is, it'd be similar concepts to charging up a big capacitor on a current limited supply. It's not just going to be up to voltage like that. Do you know what I mean? I can't think of a good analogy to explain it, but the point I'm getting at is I reckon having big diodes here like this is probably going to create less distortion than having little ones. If you are, you know, experienced in this sort of thing, leave it in the comment section if you got an answer to that question or that statement, or theory is the word I should be using. Alright. This is actually a lot simpler than it looks, because it's actually a jumper from there to there, a jumper from there to there, and then from there to there, and from there to there is the 120 ohm resistors. From there to there's a jumper. And then from this point again to here, and from here to here is the 560 ohm resistors. And then from this point to these 2 points is where the pots go. So it's actually quite simple. I'll start with the 560s. Actually no, I'll start with the 120s because they're at the back. I think I'll do these ones standing up. Actually no, you know what? I don't want to do that because this is going to be in a box with space constraints. Didn't think about that. Could drill holes and put them up from the bottom, mount everything from the bottom. I didn't want to put anything higher than the top of these diodes because I wanted to put this in a box. Could always just go for a bigger box, I guess. Yeah, I can always just go for a different box to the box I was going to buy. And then I don't have to worry about the height. I might go for a sort of like a rack mount case. Actually, I've got something in mind. If anyone watches Astro 30, shout out to Astro 30. He built an amplifier recently. It was his 200 watt PA amplifier or mixer amplifier. I can't remember what it was. It was 200 watt amplifier. He did a good job on it. Nice choice of output devices too. Anyway, the case he put that in, I recall the heatsink. I remember looking at the heatsink and the board and the power supply and that, and it was sort of sitting down in the case and there was a bit of space above it. I might get a case like that. Yeah, that's what I'll do. Then I don't have to worry about this space up on the top of the board so much. Alright, so I think, yeah, I'll do what I was going to originally do and lay the resistors out standing up. Maybe I should have tried to do that individually. Oh well. Let's go for it. I'll just do a couple of these and again I'll pause the video. Actually, I'll pause the video whilst I make them up because this is going to be a little bit of fiddling around. I've got to cut the legs a bit shorter than what I made them. I just realised you guys can't really see me making up components anyway on the camera down here. Shit. I'm sorry. I didn't even realise that. It's kind of hard fitting everything in my defence in this space that I have here and keeping it all on camera. That's why I was saying earlier about me wanting to make a better camera setup that I can also angle the phone, the camera. It's not that I don't try, it's just that the space is not ideal. Ah, damn it. I'll pause and I'll get this done. Alright, I got these 4 ready. Hold on a minute. Why do I have 8? What am I missing? I think I am doing something wrong. Because 1, 2... Oh man, you know what? I think somehow I've laid this out wrong. I'm going to have another look at this. Something doesn't make sense here. I'm going to have to pause. I'm actually a genius. No, I've done it right. Where I said there's a jumper that goes from there to there, there isn't. The first 120 ohm resistor goes from there to there. The second one goes from there to there. The third one goes from there to there. The fourth one goes from there to there. The 560s go from there to there and from there to there, and the pots go here. So it's all good. It just, you know, looking at that, it looks a little bit confusing. I'm sure you guys are looking at it too going, I'm glad you can work it out. So am I, trust me. I think I have to put 4. I confused myself before. Well, we're definitely going with a bigger case now. So now I need to put 560, 560. I should have got them ready. I wasn't thinking. I'll just pause again. Alright, got a couple of 560s ready to go. Alright, lucky last. Ow. Fuck. That hurt. A couple of those just looks like they could do with a bit more solder. Like I said, the bias string is the last thing we need to come up. Especially whilst the amp's turned on, that would just be terrible. I don't like that resistor, it sits up too high. That's the problem with me. Little things annoy me. You watch me make a mess of this trying to make it neater. Actually, I think I can do this. Yeah, I got it. Cool. This is very awkward. I don't know why I tried to do this. I always do dumb things and regret them. Alright, let's get that resistor back down. All for the sake of being neat when nothing on any of these boards is measured or neat or accurate in terms of being the same as the other board. God, my mind. Works in strange ways, it does. Alright, so now the pots, we basically have to connect the end of the track with the wiper, or just one end of the track obviously. Oh, that's good. It's just going to fit where I want it. Oh, that's lucky. That's why I put the curve there on that track, because I knew that I had to join the end of the track to the wiper. Well, there's one pot. Can't get simpler than that. Hey, no playing in here. Cats. There we go. Brilliant. Hey, no playing in here. Get out of there. Hey, that's all my work. Get out of there. Out. Thank you. Now this cat's rubbing on my leg. Ah, now it's jumped back up on the table. Get out. Alright, I'm going to have to get the cats out. Sorry, guys. Alright. Beautiful. That is the bias board complete on that amp module, whatever you want to call it. So there you go. That's one complete. Now we just need to do the other one. It's coming along. I'll bring it up to the camera for a close look soon. Alright, I'll get these resistors made up off camera, and then I'll come back and put this together. Actually, I'll do this off camera and I'll just come back and show you when it's finished, because you just watched me do the other one. No one wants to watch someone build something twice, I don't think. I don't know if anyone can see this, but that scratch light patch there also goes through here very lightly. The reason I haven't patched that is because when I solder the wire on there, it's going to be covered in solder. I don't even know if any of you can see it, but just thought I'd point that out. I'm going to do the last of these resistors and everything on camera. It's the last little bit anyway. I'm getting too tired, it's getting confusing for me. Yeah, that goes there. That goes there. Something doesn't add up here. 1, 2, 1. Oh, 2, yes. And then the 560s. It's confusing me because I've laid this one out slightly different. But there we go, I've worked it out. Alright. Start off with the 120s. Oh. Now that one's, oh my god. I'll have to come back and resolder that. Alright, let's get some fresh solder on there. Okay. More resistors. It's funny, as I've been building this thing, I haven't had to look at the schematic once, even though I designed this like 3 years ago and it's slightly different to the original. It's still all just, you know, coming back to me as I'm doing it. Yeah. Alright, we'll do the 560s and the pots and call it a night. I'll resolder them after. Why am I confused with the last one? Oh, it goes here. It's weird when you've made a board slightly different to another board, even though it's the same thing, because the traces are in a slightly different spot. It's actually a little confusing. Well, there's one pot. By the way, I designed this amp so that when you start the setup on it, the pots should be in the middle. Now, that was with the original transistors that were in it. So these ones could have different gain and different properties, and the bias could be not where it used to be, and this could be miles off. That's only if it still is the way it was, if that makes sense. What have I done wrong here? Nothing, it's just my layout that's not the best. It'll fit, I'm just going to have to MacGyver it a little bit. I could also fix it with copper tape, make the track a little bit longer, but I'm not going to do that. Oh well, the pots aren't in exactly the same spot on this one. I'm going to leave a nice big blob, just because those legs are on like towards the edge of the pad. I don't want them to end up free. These 500 ohm pots are across. I'll just show you the circuit diagram quickly just for reference. I've designed it so even if the pot goes open, the bias doesn't go up by very much. You see the pot's a 500 ohm pot in series with a 560 ohm resistor across two 120 ohm resistors, so it doesn't have much of an effect. It's only for actually setting the bias. It's not for when I say setting it, I mean within a couple of millivolts, just to make the two channels even and to get the bias number where it is supposed to be. Anyway, that's all I've got for tonight. That's the end of this video. I'm not going to do any more on this till tomorrow. I'll bring this up to the camera so you guys can have a quick look at them. So that's our bottom. Farnell tip 41s on one side, on semi on the other. So that's what we've got. All right. That concludes this video. I guess I'll see you all tomorrow. If you like my content, please give me a like and a sub. I thank you all, and I will see you in the next video.